Hello guys, and welcome back to the CCNA video series brought to you by ABY Design and Tech. In this video, we're going to shift our focus and now look at variable length subnetting. So still, we're focusing on subnetting, but this is the pinnacle of subnetting. So, learning objectives: to understand what variable length subnet masks are and to understand the process of variable length subnetting. So, let's just dive straight in, guys. So, the first question you guys probably have, Abda, wait there. What is variable length subnetting? Well, simply put, we're just using different size subnet masks throughout our enterprise, and that's all there is to it. So Abda, what's so special about this? Well, so far, we have been focusing on fixed length subnetting. That is where we choose one subnet mask and we use the approach of one size fits all. So we apply that subnet mask to all of our LAN segments. It doesn't matter whether there's 2 devices, 10 devices, 100 devices. We use the same subnet mask throughout our enterprise network. Now, there is still some benefit to that because obviously we're subnetting, we're still saving IP addresses. And to be fair, to create your subnet plan is very, very easy because you're only focusing on a single subnet mask. However, we can still be so much more efficient if we just used variable length subnetting. Just use a subnet mask different for each LAN segment, and this is the beauty about VLSM. We can tailor the subnet size for each LAN segment in a very, very specific manner. So, as an example, if a LAN segment has 50 hosts, we can use one subnet mask for that LAN segment, and we can use a different subnet mask for a LAN segment which has got 2 hosts. So now we're tailoring the experience towards the LAN segment, towards how big that LAN segment is. And this helps us account for VLANs of different sizes. We may have, let's say, the sales VLAN. We have a massive sales team. It's got 300 people in that team. They all got devices, etc. However, we've got a very, very small IT team. We may only have 20 people in that team, and therefore there'll only be 20 devices. We can create subnets of different sizes to waste a few addresses as possible and have more addresses left over that we can use elsewhere. Now, let's go through this process. Again, let's go through an outline and then we'll dive in with an example. So, let's list, first of all, we list each LAN segment in order from largest to smallest. Next, we work out the subnet mask for the first segment. Then, we assign that subnet to the largest segment. Afterwards, we work out the subnet mask for the next largest segment. Then we assign that a subnet and make sure it does not overlap with the first segment. And we repeat this process until we have assigned each segment a subnet, and that's all there is to it. So now, watch me work through watch me work through this with a real life example. Okay, so in this example, I'm using, what a surprise, Class B network 172.16.0.0/16. This is my small network. So I've got 2 what we call WAN links. WAN links are essentially just links which connect your different sites together. So as an example, these may be branch sites. So we may have the headquarters site, which may be in San Diego. We may have a branch site maybe in London and another branch site maybe in Mumbai. So they're in different areas. And so the reason why we can tell that this is probably the headquarters site because it's got the most number of hosts. It's the largest subnet. We've got our point-to-point WAN links, and we've obviously got these 2 small subnets. Now, if we were to use the same subnet mask throughout the enterprise network, we would be getting massive wastage of IP addresses in most of our segments, because obviously we would have to account for our largest subnet. That's going to be this subnet over here, meaning we would need 8 host bits, which gives us a /24, which allows for 254 usable IP addresses. Well, guess what? We would have to use a /24 over here, over here, over here, and over here. On the WAN links, you're going to be wasting 252 IP addresses, and you'll be wasting a whole load more on these 2 subnets over here. So now let's go through the VLSM process. Step 1, list out the requirements for each segment starting from largest going to smallest. So the largest one is 220 hosts. The next largest is going to be 50 hosts, and then we need to have 30 hosts over here, and then we need 2 hosts and then 2 hosts. Great. Now, I need to work out how many host bits I need to meet the requirements for every single segment. So as an example, for 220 hosts, I need to have 8 bits. That gives me a /24 subnet mask. For this one over here. Okay, 50 hosts. Okay, so 2 to the power of 6. So 32 minus 6. So why am I doing 32 minus 6? Well, I know that the maximum number of bits in a subnet mask will be 32. And I know I only need to have 6 host bits in order to meet this requirements and waste as few IP addresses as possible. So I simply just do some simple math. 32 minus 6 gives me 26. That means the subnet mask I will use for this segment over here will be a /26. Now moving on to this guy over here. 30, that's going to be 5. 32 minus 5 is going to be 27. My subnet mask for this one's going to be a /27. And for these two, this is a bit tricky. So we can't just use one host bit, because remember the formula, guys. To work out the number of usable host IP addresses per subnet, we do 2 to the power of minus 2. So if I have one bit, that gives me 2 IP addresses, but neither of them can be used because the first IP address will be for the network, or the subnet will identify the subnet. The next IP address will be the broadcast IP address, so I can't use either. So I in fact have to use 2 bits for this, which will give me a /30 for both of these. And so 2 bits allows for 4 IP addresses, 2 which cannot be used and 2 which can be used. So let's now do some subnetting wizardry. Okay, so we've got our subnet masks. Now let's start assigning our subnets out to our different segments. And again, we start with the largest segment. So I'll be using a /24 mask for this segment. So I literally just use the class B network and just stick a 24 mask on it. So 172.16.0.0/24. So that's the first subnet I'm assigning out, was a /24 mask to this largest segment over here. Next, let's go to the next largest segment, which is going to be this guy over here. So what do I do now? Okay, I know I need to use a /26 mask. I need to work on my increment. So obviously I know that my subnet mask in decimal is going to be as follows. So 255.255.255. something. So I know that in the last octet, I'll have 2 binary 1s followed by 6 binary 0s. Let me write this out in my chart. So 1, 1. Don't really have to go any further because I know these are all going to be 0s, etc. And my increment is going to be 64 in that 4th octet. Brilliant. So would you start listing out the subnets? 64.128.something.something.something? No, I wouldn't, because obviously I know, well, I can't use any subnets within this range because that's already being used by this guy over here. And by the way, the next subnet, or the next available subnet for this guy, will be 172.16.1.0/24. Now obviously I'm using this first subnet over here. I can't use any of the address ranges from within this subnet. So for this guy, I know my increment is going to be 64. So let's start going up in 64. So 64, we got 128, 192, and then we get to 256. Okay, so 256, I carry over the 1, that gives me this. I'm going to assign 172.16.1.0 with a /26 subnet mask to this guy over here. This is why it's so important to start with the largest subnet first. We start with the largest subnet, assign it to our segment, and then we work through the smaller subnets to make sure we don't have any address overlaps. And this is what I've done over here. Now, let's move over to our second subnet. Our third subnet. Okay, so let's do this. Let's focus, guys. Come on. Let's keep up the energy. Okay, so 30 host /27. What I usually do, so this is what I normally do. See over here, I listed out my next subnet ID. Okay, brilliant. I'm going to list out my next subnet ID over here. Okay, well, let's go through the subnet. My next subnet ID would be 172.16.1.0, .64, sorry, /26. So Abdul, why did you list out your next subnet ID? Well, the reason being, and this is the reason, we cannot use a subnet which sits in another subnet. So as an example, if I were to use as an example 172.16.1.0, and let's go for /27. Yes, that's a valid subnet ID. But can you see the issue? It overlaps with this guy over here. And that the IP address range presented by this subnet sits within the IP address range presented by that subnet. This is again why we start with the largest subnet and then work our way down. So I simply just list out the next usable subnet. So anything beginning with .64. So now I know that my next subnet that I can use is going to be 172.16.1.64/27. That is going to be my next usable subnet. So I'm going to assign that to this guy with a /27 mask. And obviously we know that a /27 mask allows for 3 binary ones. We enter another binary one over here, and that gives me an increment of 32. So by doing some maths, I realized, okay, 32, I increment by 32 in the lost octet. And you have to understand, guys, that if I'm incrementing by 32 in the lost octet, sooner or later I'm going to reach 256. Then we're going to have to carry over the 1 and then continue counting up in 32s. That's why I just skipped that step and then just went straight to this. So I know that the increment is going to be 32. Let me just see what is the next subnet that I can use. Okay, 64. It's 172.16.1.64. Is that a valid subnet ID with a /27 mask? Yes, it is, because guess what? In the 4th octet, we're incrementing by 32, and 64 is a multiple of 32. That gives you my answer. Boom, and that is solved. Now, we need to work out the 4th and the 5th LAN segment. How do we do this? Okay. Let's do it like this again. Let's go to our next available subnet. So in this case, 172.16.1. What's 32 more than that? That's going to be 96. So the address range for this subnet is from .64 through to .95. Anything beginning with 96 and above, I can use that because that is not currently being used. Those addresses are not currently being used. So I know I'll be using a /30 subnet mask. That's going to be 6 binary 1s followed by 2 binary 0s. That gives me an increment of 4 in the last octet. Okay, well, how about we do this? Let's go up in multiples of 4. So 4 times 10 is 40. 4 times 20 is 80. Okay, 84, 88, 92, 96. Okay, well then guess what? I'm going to assign this guy over here, 172.16.1. And you guessed it, guys, you guessed it, 96./30. That is going to be assigned to this guy over here. So Albert, how did you come up with this subnet? How did you work this out so quickly? Well, let's just use some basic logic here, guys. I know that I'll be incrementing by an even number in my 4th octet. Granted. However, I know that each octet is limited to 256. So essentially, we would follow this pattern. So as an example, if I was going up with a /30, it would be 4, 8, 12, 16, etc. in the 4th octet until we get to 256. Then we'll go over and increment the next octet by 1 and then reset back to 0. And then we begin the pattern again. So 4, 8, 12, 16, 20, etc. So instead of going through and listing out each subnet like a chump, guess what I do? I use some quick shortcuts. I know the pattern that I'll be using in the 4th octet. I just go and increment the 3rd octet by 1 because that's what I'm currently working with, and then I start the pattern again. And now using that same logic, the 5th segment, that's going to be 172.16.1.100 because that's the next usable subnet with a /30 subnet mask /30, and that is variable length subnetting in a nutshell. It's beautiful, it's easy, and we've tailor-made our subnets based on the size of our LAN segments. So that's variable length subnetting covered, and as you can see, it's super easy. As long as you follow this process and you followed my logic and you use these shortcuts, you can do this in extremely quickly, so fast. Coming up next in the next video, we are going to be focusing on some variable length subnetting questions to really hammer home this knowledge. So I'll see you there. If you have enjoyed this video and you would like to see more content like this, then please subscribe to my channel. And as always, thank you very much for watching.